Hello everyone, today we'll talk about the problem find the winner of the circular game. The game is specified by two parameters, n and k. We start at player with a number of 1. Players are arranged in a circle, 1, 2, 3, 4, 5. And in every step we take k steps forward. So we start at 1, we reach 2, and that's 2 steps. And we cross out 2 from the game. We take another 2 steps, we cross out 4, another 2 steps, we cross out 1. And now we do 2 steps, so we skip over 1 who has been crossed out, we reach 3, that's the first step. We skip over 4 who's been crossed out, we reach 5. We cross out 5, and 3 is the last remaining person, so 3 is the winner of the game. And we have to return, given n and k, who wins this game. You may be already familiar with this game and with its solution, because this is just the standard Josephus problem. So you can look up the Josephus problem and find more theory about it, find some interesting solutions. The basic idea when it comes to solving the version that gives us n and k is to notice the very simple recursive definition that we can have. That's because if we have n people and k steps, right, then we can take a single step, somebody will be crossed out, and we're interested in who wins the game that remains after that person was crossed out. More specifically, if we have our function, let's say j, we can look at j of n minus 1 and k. So this is the game that starts with the first person, and let's say that we're indexing from 0 because it's easier to work with it then. So this is the game that starts with the 0th person, goes through all the n minus 1 people with the step size of k. And the only thing that we have to now adjust is that we start with those people, but we start not with the 0th person, but we first take a step of size k. So we have to add k to the result, because since we started with k people later, then the person who wins is also k people later, and of course the whole thing is happening on the circle, so we also have to modulo n this whole thing. The last thing that remains for us is that we are numbering from 1 to n, not from 0 to n minus 1, so we have to make some adjustments to the formula for it to return the same results. So the final state is that if there is only one person remaining, this person is the answer, otherwise we have to recurse with one person less. This would be the answer starting with person 1 and going of course with the step size that were given. And to adjust it, the formula is a bit more difficult. We have this +1 here to make sure that the numbers are from 1 to n. We have this modulo n, and so we have to adjust not by adding k, but adding k minus 1. So you can work it out yourself or just see that it works for indexing based on 1. You can also, if you want, write this function that returns the result with 0 indexing. So it'll recurse on itself with 0 indexing, and only at the end add 1 to the result. That's also another possibility that might be easier to think about. And also one thing to notice here, because it might seem very easy and maybe surprising that a formula like this would work, but the key to this formula, or the interesting part when it comes to this formula, is that we have this modulo n here, and of course also here, but this n changes during the runtime of the algorithm. So for instance here, in the first case, we modulo n, so that's fine, but then we recurse with n that's smaller by 1. And then if we recurse later, then we also would do modulo n, but now our n is n minus 1, so that'll be modulo n minus 1. So make sure that if you try to rewrite this algorithm iteratively, because this algorithm of course is a simple recurrence that can be rewritten in an iterative fashion, and then you will have linear time and you will have constant space, because maybe this thing will be optimized, maybe not, because it's not that easy to optimize. So if you want to rewrite it iteratively, then make sure that you notice that this n is not a constant. This n gets smaller and smaller along the way, corresponding to the fact that our circle gets smaller and smaller.